Welcome to the CompTIA A Plus certification course, your gateway into the world of IT support and troubleshooting. In this course, I will walk you through all the key topics you need to know for the latest CompTIA A Plus exam based on CompTIA's newest exam objectives. This course is beginner friendly but packed with essential skills you will need in real world IT roles. To make learning easier and more engaging, I have included clear visuals, diagrams, and step by step breakthroughs throughout the course, helping you understand complex concepts quickly and confidently. By the end, you will be ready to pass the exam and take your first step towards a successful career in IT. Let's get started. So welcome to our domain 2, that is networking, of our CompTIA A Plus course. So this is my favorite domain as I myself is network professional having about 15 years plus experience in the field. So let's get started. Our objective 2.1 is compare and contrast transmission control protocol, that is TCP, and user datagram protocol, UDP ports, protocols, and their purposes. And our first topic is TCP and UDP overview. So TCP and UDP, they are basically the core protocols of the TCP/IP protocol suite. So what does this mean? So the internet and our networks are basically run by the TCP/IP suite. You must have listened about the OSI layer. So the OSI layer is basically the theoretical model that was proposed initially to run the internet and the network. Practically, nowadays, the model that is used is TCP/IP suite. And TCP and UDP are the important and main component of this whole suite. The other important protocol is the IP. So TCP and UDP basically they handle the data transmission over the network. So we will study the detail coming slides that how does this data transmission takes place. And both these protocols basically operate at layer 4 of the OSI model, also known as the transport layer. And there are slightly differences and you can say variation between these two protocols. The only common thing you can say is that they both operate at layer 4. Otherwise, they differ in both reliability, speed, as well as the overhead over the network. So we will study all these differences in coming slides. So first of all, let's start with the TCP, that is Transmission Control Protocol. So TCP is connection oriented. What does this mean? It means that before sending data, it establishes a connection between the client and the server, and particularly this connection is known as three-way handshake. So it establishes a connection using three-way handshake, and it is known as three-way because it first sends the client sends the SYN packets to the server. The server responds with the packet known as SYN ACK, and then the client finally sends the ACK packet. So these three packets are transmitted before the actual data transfer, and that's why this is known as three-way handshake. So TCP is connection oriented. Before sending data, this connection must be established using this three-way handshake methodology. It is a reliable protocol. It guarantees data delivery and retransmit lost packets. So what does this mean? This means that it is reliable. If you send data, it will be guaranteed that it will reach the destination. If some packet are lost in the network during the process of transmission, they will be retransmitted by the TCP. And the packet are received in order. So if you send packet 1, let's suppose, then packet 2, and then So these will be received in order at the receiver. The receiver will receive 1, then 2, and then 3. And even if they are received without order, they are ordered before handing over to the destination application. And you can say the purpose or the usage of the TCP is for application guaranteed delivery. What does this mean? This means that those applications that cannot tolerate data loss, such as web browsing or file transfer, these applications use TCP. Now coming over to the next protocol, that is UDP, user datagram protocol. So as contrast to the TCP, which was connection oriented, this one is connectionless. So no three-way handshake takes place, no connection is established before data transmission. It just sends the data in bursts when the data transmission is needed. So it is unreliable as compared to TCP. So no guarantee of delivery. Some packets may be lost, and the packets are or may be received unordered. So packet may arrive out of sequence, and this application or this protocol is used in application prioritizing speed over reliability. For example, video streaming, online gaming. So when you play online game, you cannot tolerate any delay. When you press a key, you want that command to be sent immediately to the gaming server. You may tolerate some packet loss, and which will result in the poor quality of the video or of the gaming graphics, but you cannot tolerate the delay. So another analogy that just came in my mind, that you can say that UDP is like AK-47. So it just sends the data in the form of burst, like AK-47. You may miss some bullets, but some bullet may reach the target or hit the target. And TCP, you can say it is just like a sniper. So it is slow, but it guarantees the hit. Even if it misses, it reloads and then fires. So this is a crude example, but it just came in my mind. So now coming over to the ports and the protocol, and let's just few lines about the ports and protocol introduction. So ports are virtual endpoints for communication. We are talking here about the virtual ports, not the physical ports like RJ45. Virtual ports means the ports such as port 80 that is used by web service HTTP. And the purpose and the benefit of ports are that they allow multiple applications to use a single network connection. What does this mean? This means that let's suppose we have a client and we have, let's suppose, a server, and there is a single link between these two. Let's suppose they are connecting to this Cat6 cable. But this server may be running multiple applications. Let's suppose HTTP on port 80. Similarly, this server may also be running mail server SMTP on port 25. Similarly, the client may also need to remotely manage this server through SSH. So it may also be running port 22 for SSH. So by this sentence, we mean that we have a single physical network connection, but we can use this one connection for multiple applications. And the protocols use specific port numbers, such as the protocol that is HTTP, the web protocol. It uses the port 80. Similarly, the protocol SMTP. So we will study these protocol and their port number in details in the coming slide. SMTP use port 25, and similarly SSH protocol use port 22. And well-known ports, the range is from 0 to 1023 are standard for common services. So these ports that ranges from 0 to 1023, they are known as well-known ports, and they are used by the popular standard services or protocols such as port 80, 25, 22, 23. for Telnet, 21 for FTP. We will study these well-known ports and their services in. So now coming over to the some popular ports and the protocol that use these ports, and the first one is the FTP, and FTP uses two ports, 20 and 21, and the protocol that is used by FTP is TCP. So some protocol use UDP, some use TCP. So FTP uses TCP because, as we studied, we cannot tolerate file loss or data loss during file transfer. So that's why it uses TCP. So why this uses FTP uses two port number? It is because port 21 is used to control the FTP session. What does this mean? This means that when the user sends commands from clients to the server, it uses port number 21, while the port 20 is used for actual data transfer. Let's suppose when data is uploaded or downloaded from this server, then it uses port 20, such as this diagram shows. So at the client side, we have some random numbers such as 45,645, and on the server side, it uses port 21 for the, you can say, the control session, and port 20 for the data session for which data transfer takes place. So the purpose for FTP is that, of course, it is used for uploading and downloading files. Our next protocols are SSH and Telnet, and they both again uses the TCP. So SSH uses port 22, and it is basically used for secure remote access. What does this mean? This means that, let's suppose I have a client, let's suppose this is my laptop, and this is a switch, a network switch or a network router, and I am remotely configuring it. So the CLI that I am using, I may use this port SSH. I will SSH this switch, and I will configure this switch or router through CLI using this secure session. So by secure remote access, we mean that this data session is encrypted. When I send any command to this switch or server, it will be encrypted. So what does this mean? This means that even I can configure this switch or router over the internet, and all my data traffic will be encrypted, and no one will be able to interpret or use it for man-in-the-middle attack. So another related protocol is the Telnet, which uses port 23, and it is also used for remote session or for remote management of network devices. But the difference is that this is insecure. So it is insecure and it is outdated. It is same as SSH, but the only difference is that this channel or this link, when you use Telnet, it is unencrypted. So if you are given a question inside exam that you have the option of using SSH and Telnet, which one will you should use? So you should always select the SSH because it is secure and its channel or its connection is encrypted. Next are some email protocols, and these include these email protocols work on port 25, 110, and 143. So these are three different email protocols we will study in a moment. And all these email protocol again uses TCP because we cannot tolerate any packet loss during our email correspondence. So the first one is the SMTP, Simple Mail Transfer Protocol, and this one uses port 25, and it is used particularly for sending emails. Next in the POP3 as Post Office Protocol 3, and this one uses port 110, and POP3 is used to download and delete the emails. And the last one is the IMAP, and this one uses port 143, and IMAP basically sync your emails across your different devices. Next protocols are the DNS and DHCP. So the DNS uses port 53, and it uses both the TCP and UDP. So DNS uses both protocol UDP and TCP, but for different purposes. And DHCP only uses UDP on port 67 and 68. So first the DNS. So DNS stands for Domain Name System, and it uses the important point to remember here is that it uses port 53, and it is used to translate domain name to IP address. What does this mean? This means that let's suppose we have a domain name of, let's suppose, www.google.com. So the computer basically don't understand this www.google.com. They need IP addresses to communicate. So this DNS basically translates this google.com to an IP address. This IP address may be anything. I am giving just an example, 192, let's suppose 168.1.100. So this translation is done by the DNS. And DHCP, it uses port 67 and 68. And as I said, it uses UDP. So the DHCP is used to automatically assign IP addresses to the client, such as this access point, your Wi-Fi access point. It also has a DHCP server or DHCP configuration done. So when you connect to your Wi-Fi, your smartphone or your laptop automatically gets an IP address using this DHCP server or service on this access point. And so the DNS, it uses TCP for zone transfer and UDP for queries. So that's why it uses both these UDP as well as TCP, but for different functions. Our next protocols are web protocol, and we have two web protocol. One uses port 80 and the next one uses port 443, and both the web protocol uses TCP. So the port 80 is used by HTTP Hypertext Transfer Protocol, and it is the unsecure web browsing. So initially HTTP was used, but when you connect to, let's suppose, google.com or youtube.com using HTTP, it means that your session or link is unsecured and anyone in between, such as ISP, can see your data. An alternate and secure version of HTTP is HTTPS. S here stands for, you can say, secure, and it uses port 443, and it is the secure version of the web service, and it is by default the modern web browsing used by all the devices. So you won't see any HTTP website or web service anymore. And the security that is provided by the HTTPS is basically through SSL/TLS protocol. These two protocols basically provide the security to HTTPS. Our next protocols are LDAP, Lightweight Directory Access Protocol, and SMB. And these both uses port 389 and port 445, and both uses TCP protocol. So first of all, the LDAP, and LDAP, as I said, uses port 389, and LDAP is used for directory services such as user logins. And the next one is the SMB or SIPs. So these protocols are used inside Windows for file sharing, and they use the port number 445. Our next protocols are NetBIOS and RDP. RDP stands for Remote Desktop Protocol, Network Basic Input Output System. And NetBIOS uses port 137 to port 139, and it uses again both TCP and UDP, while the Remote Desktop Protocol, it uses port 3389 and it uses protocol TCP. So the NetBIOS uses, as I said, port 137, 138, and 139, and it was used in legacy Windows edition for sharing. And the RDP, or Remote Desktop Protocol, it uses port 3389 and is used for remote desktop access. So let's suppose you have a laptop over here and you want to access another laptop or another Windows computer. So you use this protocol to access the session of this remote desktop. So coming over to Objective 2.2, and this Objective 2.2 is explain wireless networking technologies. So the wireless technologies or wireless networks basically use radio signals to transmit data. And the common technology in wireless technology include Wi-Fi, Bluetooth, NFC, and RFID. And each of these technology has different ranges, speeds, and use cases. So now coming over to wireless frequencies, 2.4, 5, and 6 gigahertz, which are used by different wireless technology for different purposes. So 2.4 gigahertz is a long range frequency and it has more interferences because it is used by multiple services. It is used by Bluetooth. It is also used by Wi-Fi and microwaves. Next one is the 5 gigahertz frequency. This is Wi-Fi standard 802.11 AC used by Wi-Fi 802.11 AC, and this has faster speed as compared to 2.4, but it has less range, and as well as it also has a benefit of less interference as compared to 2.4 gigahertz. And the latest one is the 6 gigahertz, which is used by Wi-Fi 6. It is the newest, ultra fast, and it requires newer hardware, and it is used, the 6 gigahertz is used in Wi-Fi 6E. So by newer hardware means that if you have old access points, it won't run the Wi-Fi 6. You will require newer access points that are Wi-Fi 6 enabled. So now coming over to Wi-Fi channels and regulations. So regulatory bodies such as FCC in the US and ETSI in the EU or European Union basically define which frequencies and channels can be used for what purpose and how. So regulations or regulatory body vary by country such as FCC in US, ETSI EU. So these regulatory body ensures compliance with local regulation when configuring wireless network. So for example, you are configuring your wireless network, so you must ensure compliance with your local regulation that which frequency you can use for Wi-Fi and how. So the next topic is the channel selection inside the wireless channel. So what does this mean? So when we said that we have, let's suppose, 5 gigahertz of frequency for Wi-Fi, so this one frequency has then further multiple channel. You can say that multiple paths to send and receive data. So you should choose less congested channel to minimize interference. So there are multiple channels and you should look for the channels that are least congested or that minimize the interference. So you can use different tools to analyze channels that are used in environments such as Wi-Fi analyzer. We will study Wi-Fi analyzer in a while. And overlapping channels can cause significant performance degradation. What does this mean? This means that let's suppose you are using a channel number 1 and the same channel is, let's suppose, also used by another access point nearby. So since these both are using same frequencies and same channel, so there will be interference and performance will be degraded. So what is the channel width? So as I said, we have different channel and each channel has a frequency width. So wider channel means have faster speed, but we will have more interference because more channel will fall in the same channel width. For a common channel width are 20 megahertz, 40, 80, and 160 megahertz. So this 160 megahertz will have the highest speed, but it will also have the maximum interference. So you should trade off between the interference and the speed. So you should choose the width based on the device supporting the width and your network needs. So now the next topic, the frequency and bands. So different frequency bands. So these are known as bands. So we have the 2.4 gigahertz, 5 gigahertz, and 6 gigahertz band. And then each of these have different channels allocation. So 5 and 6 gigahertz generally offer more non-overlapping channels compared to 2.4 gigahertz. So as we said earlier, 2.4 gigahertz frequency band has more interference as compared to 5 and 6 gigahertz because the channel allocation in 2.4 has more overlapping channels. So using non-overlapping channel is key to reducing the interference in dense environments. So let's take an example. Let's suppose we have 2.4 gigahertz of bands. So in this 2.4 we have multiple channel, and channel 1 basically uses frequency range from 2.401 to 2.423 gigahertz. Then channel 2 starts from 2.406 gigahertz and overlaps with channel 1. So you can see that this is the range of channel 1, while channel 2 is also starting from 2.406 gigahertz. It means this lies between in this range, so there will be interference and it actually overlaps with channel 1. So in 2.4 gigahertz, the channel 1, 6 and 11, they do not overlap with each other. So when you are using 2.4 gigahertz and your device supports the channel selection, then you should select these channel because they are non-overlapping channel. So now some comparison or summary of the 802.11 Wi-Fi standards. So 802.11a, it has the speed of maximum speed of 54 megabit per second. It uses 5 gigahertz frequency band and it was introduced in 1999. 802.11b has 11 Mbps speed. It uses 2.4 gigahertz band and it was again introduced in 1999. 802.11g has again 54 megabit per second speed. It uses 2.4 gigahertz frequency and it was introduced in 2003. 802.11n, also known as Wi-Fi 4, has 600 Mbps speed. It uses both the 2.4 and 5 gigahertz frequency bands and it was introduced in 2009. While 802.11ac, also known as Wi-Fi 5, it has a maximum speed of up to 3.5 gigabit per second. It 5 gigahertz frequency band and it was introduced in 2013. And the latest and newest is 802.11ax, which is also known as Wi-Fi 6 and 6E, and it has a maximum speed of 9.6 gigabit per second, and it uses 3 frequency bands, 2.4, 5, and 6 gigahertz, and it is used 2019 onward. So now coming over to another wireless connectivity technology, that is Bluetooth. So it is a short range wireless technology for connecting devices. You can say it is the one of the shortest range technology as compared to other wireless technologies such as cellular, Wi-Fi, and it is used for accessory nowadays such as headphones, portable speakers. It can also be used for file transfer between smartphones and laptops, and it operates in 2.4 gigahertz frequency band. So that's another reason for 2.4 gigahertz frequency to be congested and has performance degradation. Next is the NFC, that is near field communication. So this is a very short range, even shorter than the Bluetooth. It has a range of few centimeters, and it is used in contactless payments for quick pairing such as this one. So nowadays we have NFC enabled ATM, and if your mobile is also NFC enabled, you can do payment through NFC, which is contactless, and it is secure and it uses very low power because it works at very short distances. Next one is the RFID, that is radio frequency identification. So it also uses radio waves to identify and track tags attached to the objects. And tags can be passive, that means the tags do not require any battery, or they can be active. They are battery powered. So it is used in inventory management, access control, and toll systems, such as here we can see that this user is doing inventory management by scanning the RFID tag on this package. So different frequency ranges with varying read ranges. So it also uses different frequency and has different read ranges. Some has small range, some may have longer distances of reading the tags. So objective 2.3, summarize services provided by networked hosts. And the first service is the DNS server. The DNS server provides the DNS service, that is domain name system. So DNS basically translates your domain names to IP addresses, such as when you type www. Let's suppose google.com, that is a domain name and that is translated by DNS to an IP address such as 192.168.1.1. So this is the private IP address I am giving just for an example. So that's the basic purpose of the DNS server. And it allows users to use websites name instead of IP addresses. So it is easy to remember www.google.com as compared to the numbers such as 213.86.61 and so on. So that's why we use the domain name. An example is again google.com translated to this IP address. Next service is the DHCP, that is Dynamic Host Configuration Protocol. And this protocol is used to assign IP addresses automatically to the clients inside the network. And besides the IP addresses, the server also provides the subnet mask gateway as well as the DNS info. DNS info means the DNS server. And this protocol basically saves time and avoids conflicts. What does this mean? So if you have, let's suppose, 100 clients inside your network, and if you want to manually configure assign static IP addresses, subnet mask, gateway, and DNS server to all these clients, it will take a lot of time. And you may also give two clients the same IP address and you have the conflicts. While the DHCP server, it avoids conflicts. It does not assign same IP address to multiple clients, and it assigns the IP addresses automatically without any manual configuration or intervention. Next is the file share server. So these servers are used to share files between clients and servers over the network. File share server or file servers are basically centralized location for storing and accessing files for the clients. So they support permissions as well as access control. So if a client has the permission and has the access permission to the files, only then will the server allow the access to the files. And the common protocols used by file share servers are SMB and NFS. Next are the print servers. So these servers basically manage print jobs from multiple clients. So you have a print server inside a network, and your multiple clients inside the network can give print commands to this print server, and this server basically manages the print jobs and print queue from all these clients. It also controls access to network printers. So each client must be first configured and allowed to access the print services. And it is also the centralized location to track usage and printer status. So this print server basically logs the number of prints that has been given by this client as well as this client. So this is also a centralized location for monitoring your print usage, as well as the print status means the printer cartridge status as well as its health. Next are the syslog servers. So these servers basically collect and store system logs from different devices and other servers. And it is basically a centralized location for logs, and these logs are then can be used to monitor and troubleshoot different servers inside your network. And syslog protocol basically uses UDP port number 514. So this is important to remember. And one of the popular syslog server or service is SIEM, that is Security Information and Event Management. So this is a specialized solution that is used. For example, if I give you an example, QRadar is a popular SIEM solution from IBM, and this solution is used basically to collect logs from all network devices from different servers, and then here centrally you can then give configure different rules, policy violation, and this is a very popular solution. So this is a generic term, the syslog server, and this is one of the syslog server solution, QRadar from IBM. Another popular solution is the Splunk. The IBM and Splunk, these are the industry leading solutions. So next network host are the web servers. So these basically deliver websites and web application or HTTP and HTTPS protocol. As we studied, HTTP is the unsecure or unencrypted, and HTTPS is the secure version of the web server. And it hosts HTML, CSS, JavaScript, and media files and pages. And the common software that hosts the web servers are Apache, Nginx, and IIS. This is from Microsoft. AAA servers, that is authentication, authorization, and counting. So authentication basically verifies the user identity, such as when you log in your username and password, this is done through the authentication. Authorization then grants user the access to different rights. So first you authenticate, and then you are granted the access based on your user. And the last step is the accounting. So when you perform certain tasks inside the application or the server, your each and every activity is logged or tracked using the counting service. Next are the important database servers. So they basically store, manage, and serve data for all the applications. So database is basically at the back end. At the front, you have the application interface. But when you enter data or you save data or you retrieve data, it is all done from the web, from the database server. So this database server basically understand or use structured query languages such as SQL or SQL. And as I said, it is backend for the web application and business tools. Next is the NTP, that is Network Time Protocol servers. So these servers basically synchronize time across all the devices on the network. So it is very important that all the devices on the network have the same time inside their devices or services. And it is critical for these services, specifically for logs, authentication, and coordination. And NTP uses UDP protocol on port 1 to 3. So a quick quiz time: which server role assigns IP address to devices? And the options are option A DNS, option B DHCP, option C AAA, and option D NTP. And the correct answer is I hope you people know the answer. We just studied it. It is DHCP, Dynamic Host Configuration Protocol. DNS is used to translate domain name to IP addresses. AAA is authentication, authorization, and accounting. And NTP is used to give a centralized time to all devices inside a network. So basically, the NTP server works such that your all devices, let's suppose you have different devices inside network, this is your NTP. They ask for the time from this server. So this, you have one source of time inside network. So all these devices basically have the same time. Next topic is the internet appliances, and the first appliance is the unified threat management, that is UTM. So UTM basically combines multiple security functions in a single devices, and these functions may include the firewall, intrusion prevention system, that is IPS, antivirus, anti-spam, and web filtering. So usually we have dedicated device for firewall, IPS, antivirus, and other application, but UTM combines all these services to a single device. So it simplifies security management. So instead of having, let's suppose, 5 or 6 devices, you have a single device. So it gives simplification and easy management. And it provides comprehensive protection because you have multiple functions inside a single device. Next appliance is the spam gateway. So spam gateway basically analyzes the incoming email traffic inside your organization. It identifies and blocks spam emails and phishing attempts. It improves email server performance because all the spams are basically blocked and they never reach the email server. It also enhances network security because the threat from the phishing attempts and spams are blocked by the spam gateway. Next is the proxy server. So proxy server basically acts as an intermediary between the clients and the server. You can say that, let's suppose you have a client, and let's suppose you have a web server over here. So the proxy basically sits between your clients and the server, and it filters or it monitors all the requests from the client to the server. So it can improve security by hiding internal IP addresses. What does this mean? So it means that this server will see the IP address of this proxy. It will not see the IP addresses of the internal clients. It can improve performance through caching. What does this? This means that, let's suppose, this clients access a web page from this server over the internet. So this page is basically cached over here. And next time when another client wants to access the same page, it doesn't need to go all the way to the internet. It will be, it is available and is provided by this proxy server. So you can say that it can also act as a cache server. So it can also control web access. So let's suppose you can implement web traffic control. You can blacklist different IP addresses, different malicious websites over here, or even social media sites. Let's suppose your organization wants to restrict user to specific servers and wants to prevent Facebook browsing. So you can block Facebook application through this proxy server. So now summary of the internet appliances role. So the spam gateways are used for stopping the unwanted at spam emails. UTM basically it is all in one security box that combines multiple security functions such as IPS, antivirus, and firewalls to a one security box. Load balancers basically share the traffic load between multiple devices. So we didn't study load balancer in detail. So load balancer, let me give you an example. So this is a load balancer, and these are, let's suppose, different web server. We have web server 1, web server 2, and web server 3. So this load balancer has multiple advantages, and here are, let's suppose, our clients. We have, of course, multiple clients. So when these clients wants to access the web servers, they first come to the load balancer, and load balancer then distributed the loads among these servers. So let's suppose client 1, 2, and 3. Client 1 comes and the load balancers forwards the request to, let's suppose, web 3. Then client 2 request is forward to, let's suppose, web 1, and client 3 request is forward to web 2. So this way the load is equally distributed among servers, so it enhances performance. Another advantage is the availability or failover. So let's suppose our web server 2 fails due to any reason. So now the load balancer won't transfer any request to web server 2. It will transfer the request to the remaining available server. So user won't experience any downtime or any interruption of the services. So these are some of the advantages of load balancer. And proxies, as we studied, it filters and protect internet access from the external network. Our next topic is the legacy and embedded systems. So these systems basically run on outdated or fixed purpose hardware and software. So in industry, we have some hardware that are for one specific purpose, but they are outdated and legacy. So these are still used in industries because they are very costly to replace, and compatibility is another issue. So these legacy systems often lack modern security features because they are outdated and they cannot receive updates. So one of these systems is the SCADA, that is supervisory control and data acquisition. So this is a type of industrial control systems. It is used to monitor and control industrial processes such as power plants, water treatment facilities, nuclear power plants, etc. And this it basically relies on specialized hardware and software. And for connectivity, it uses industrial network protocol. So it does not use the regular TCP/IP. It has specific special purpose industry network protocol. And security is a critical concern because if these protocols are disrupted, it means your whole power plant or your water treatment facilities may be disrupted or even contaminated. Next topic is the IoT, that is Internet of Things devices. So these are basically the network of physical objects known as things that are embedded with sensors, software, and other technologies such as these things. And they enable data exchange with other devices and systems over the internet. They have a wide range of applications such as they are used in smart homes, and wearables such as your smartwatch, and also used in industrial Internet of Things networks. So for connectivity, they primarily use wireless networks such as Wi-Fi 802.11 standards. They also use Bluetooth, NFC, cellular network, and LPWAN. Security and privacy are significant concern for these IoT devices. So what are some challenges with the legacy SCADA and IoT? The first one is that these systems are legacies, particularly the SCADA and industrial system. So they often lack modern security features, making them vulnerable to latest attacks. The challenge with embedded system or SCADA is that they operate or they are embedded inside, used inside critical infrastructure such as power plant, and security breaches inside these systems can have severe consequences, such as you can say that Beside the physical attacks, the power plants in recent Russia-Ukraine war, the power plant infrastructure were also targeted through web attacks, cyber attacks by Russia inside Ukraine power plant, and they were disabled or shut down for multiple hours or even days. IoT, so vast number of devices create a large attack surface. Privacy is also a concern. What does this mean? This means that if you have inside home multiple devices such as your light bulbs, your TV, your refrigerator, all these have connectivity. It means you have a large attack surface. Any of these devices can be uh, penetrated by the attacker. Privacy is also a concern. So if one of your devices, let's suppose your smart TV is compromised, it means that smart TV has has camera, it has also has mic. So anyone can use these cam and mics of your smart TV to compromise your privacy inside your home. Security is a paramount concern across all these specialized systems. So a quiz time, a quiz quick. Which type of system is most likely to control a city traffic lights? Options are option A, IoT device, option B, SCADA, option C, legacy embedded system, and option D, proxy server. And the correct option is option B, SCADA. And our objective 2.4 is explain common network configuration concepts. And our first topic is DNS record types. So we studied the DNS, that what is DNS. Now we will study different DNS record types. So DNS records basically stores information about a domain. So different record types serve different purposes. First one is the A records. So A record basically maps a host name to an IP version 4 address. For example, example.com may be mapped to 192.0.2.1. Next is the Tetra A record. So this basically maps a host name to IP version 6 address. For example, example.com may be mapped to an IP version 6 address. Next record type is the CNAME, which is the canonical name. So it creates an alias for another host name, that is the canonical name. For example, www.example.com may have an alias of example.com. And the last one are the MX records. So these basically specifies mail servers responsible for accepting email for a certain domain. For example, example.com may have an MX records of mail server.example.com. So example.com domain have the mail servers as MX record. Next are the TXT or text records. So these holds basically text data, and these are used for various purposes including domain ownership verification and spam prevention. So remember, it is important that the text or TXT records are used for spam prevention, and spam prevention techniques include SPF, DKIM, and DMARC. So we will study now these one by one. So DKIM is basically domain keys identified email. So it adds a digital signature to your emails. And what does digital signature do? It verifies that the email was sent by an authorized mail server for the domain. So if your device receives an email from a domain server that is not authorized by DKIM, it will be flagged as unauthorized or as a spam. Next one is the SPF, that is Sender Policy Framework. So it specifies which mail servers are authorized to send email on behalf of a domain. It also prevents email spoofing. And last one is the DMARC mark, which is domain-based message authentication, reporting, and conformance. So it builds on SPF and DKIM. So it specifies how receiving mail servers should handle emails that fail SPF or DKIM checks. So this means, what does this mean? This means that if an incoming email check one of these steps, SPF or DKIM, then what should be done with that email? It is decided by the D mark. Our next topic is regarding the DHCP different concepts, and the first one is the DHCP leases. So what is DHCP lease? So DHCP assigns IP addresses for a limited time period called a lease. So this is the lease. So you can configure that for how much time the IP address should be assigned to a client, and when that time passes, the IP address is renewed by the client. So here we can see that the lease time is almost, I think this is 24 hours. This number is in seconds. So you can configure this inside your DHCP configuration. So devices must renew their lease periodically to maintain their IP address. So after this time, the device must, before this time, the device must renew its IP address, so that and when the IP address is renewed, the lease is also renewed. So it allows for efficient reuse of IP addresses on the network. So let's suppose a device disconnects itself from the network. So if a device does not renew its IP address after this lease time, it means the device has gone or has shut down, and this IP address will then be assigned to another client. So in this way, it allows for efficient reuse of IP addresses to the client. If a client is shut down due to any reason, its IP address will be assigned to another client after the lease time. Another concept is the DHCP reservations. So DHCP reservation basically allows administrators to assign a specific IP address permanently to a particular device. So you can configure that. Let's suppose this IP address 192.168.100.10 is always assigned to my laptop. You will give the MAC address and the IP address, and you can also give the description. So each time the DHCP server, when you connect your laptop to the network, your laptop will always be assigned this IP address. So it is easy for efficient for efficient management, because you always know that your laptop has an IP address of 100.10. It can also be used for other servers, such, let's suppose you have a print server at your network. So and you have let's suppose multiple clients. So your client should know the print server IPs. So if the print server IPs changes each time, it will be difficult for the client to give the print commands. So you can reserve a specific IP address for the print server, and the clients will always know that our print server has the same IP address. So the reservation is typically based on the device's MAC address, and it is useful for servers, printers, or other devices needing a consistent IP address. Another important concept is the DHCP scope. So it is basically the defined range of available IP addresses. So when you define a DHCP or configure a DHCP server, you will need to give the DHCP scope or the DHCP range, which you configure by giving the starting IP address as well as the ending IP address. So the DHCP server will now assign IP addresses starting from this 80 up to 90. And if let's suppose these are, let's suppose 11 IP addresses, and you have, let's suppose 12 clients. So when the 12th client comes, it won't be able to get any IP address, because the range or the scope is exhausted. So you can then increase the scope or increase the range. For example, as in this example, the range is, or the scope is 192.168.1.100 up to 192.168.1.200. So you have almost 100 or 101 IP addresses in this scope. So must match subnet mask and gateway setting. What does this mean? This means that your gateway must also be in the same network, and your subnet mask must also match this scope. So, for example, if you have a gateway 192.168.100.1, it won't work because your scope is in 1.80 network or 192.168.1 network, but your gateway is in 192.168.100 network. So here it must be 1 as well. Another concept is the DHCP exclusions. So DHCP exclusion is the IP addresses excluded from the automatic assignment. What does this mean? This means that you exclude certain IP addresses from the DHCP server, and DHCP server won't assign this IP address to any server or any device. And then you can use this IP address to manually give it to your devices. So the difference between exclusion and reservation is that in the reservation, the DHCP server basically assigns the IP address to the same device each time based on the MAC address, while the exclusion exclude the IP address from DHCP server assignment altogether. You can use those excluded IP for any purpose. You can manually assign these IP addresses to your devices. So they are used for static devices outside the scope, and it prevents IP conflicts. So let's suppose you have given a static IP address to a device and you have not excluded the IP address inside DHCP configuration. So the DHCP server may also assign same IP address to another device, and you will have conflict. But once you have excluded this IP address in DHCP configuration, it will no longer be assigned to any device. Another important concept is the VLAN, that is virtual LAN or virtual local area network. So what is a VLAN? It is basically VLAN logically divides a physical network into multiple broadcast domains. So by default, when you connect your devices to a network switch, by default this switch has a one broadcast domain and all the devices are in the same broadcast domain. But when you configure different VLANs inside the switch, each VLAN is now a separate broadcast domain. And why we do use VLAN? So we improve security. So for example, if we want that the traffic of this device should not be listened by these devices, so we can configure this device in a separate VLAN and this device in a separate VLAN, so their traffic is isolated. As we said, they have separate broadcast domain, so when this device broadcasts a traffic, it will not be listened by this one or this one. When this device broadcasts a traffic, it will be listened by this one but not by this one. So it also reduces congestion because it limits the broadcast traffic, because now we have multiple broadcasts and the traffic is limited to a specific broadcast domain. And it also simplifies management, so it groups devices by function, so you can it is easy to manage these devices, and you can, let's suppose, apply different policies on these devices by groups. For example, as we can see in this example, you can use VLAN 2 for accounting. Accounting people will be, their client will be configured in this VLAN, and you have another VLAN 3 for marketing. So marketing clients will be in this VLAN. So the client inside accounting and marketing won't be able to communicate with each other for security. Similarly, if you have other clients such as guest, you can use another VLAN for them. So you can configure theoretically 4096 VLANs. So this is the range of the VLANs. The first VLAN number 1 is basically reserved. It is the default VLAN of this device, and you can configure onward VLAN 2, 3, 4 up to 4096. So some other concepts about VLAN. So for implementation, you need VLAN capable switches. So the simple switches, or you can say the unmanaged switches, they are plug and play, and they don't give the option of VLAN configuration. But the modern switches, they have the capability so that you can configure them for different VLAN. So the device must be capable of VLAN, and VLAN basically uses tagging mechanism, that is it uses IEEE 802.1q standards. And if you want to, as we studied in the previous example, let's suppose we have multiple VLAN, VLAN 2 and VLAN 3. So if there is a need that you want that VLAN 2 and VLAN 3 should be able to communicate, then you need a layer 3 device or router. So if the switch is layer 3, nowadays almost all the modern switches are layer 3. Layer 3 means that they can also perform basic routing. And the port types of VLANs can be access. So the access means that a single device is connected to the port. For example, your laptop will be connected to access VLAN. Trunk port basically carries multiple VLAN. Here we can see that this switch has multiple VLANs, 3, 4, 2, 1. Similarly, another switch which is connecting another building with this switch, it also has multiple VLANs. So this port or this cable between these two switches must be trunk, because it will need to carry VLAN 1, 2, 3, 4. So when you need an interface or a port to carry multiple VLAN, it will be configured in trunk mode. But when a single device is connected to a port, that port will be in access mode. Another important concept is the virtual private network, or VPN. So VPN is used for encrypted tunnel over public network. So let's suppose you have a client over here and you want to access some data, secure data over the public network, that is internet. Then you will use the VPN, and VPN will encrypt your connection. So why we use VPNs? To access private networks remotely, bypass geographic restriction. What does this mean? This means that let's suppose you live in a country X where, let's suppose, Netflix is not allowed. So what you can do, you can configure VPN and you can change your location using the VPN to another country Y where Netflix is allowed, and this way you can bypass the geographic restrictions. And it is also used for secure public Wi-Fi connection. So let's suppose you are using Wi-Fi inside a cafe, which is not very secure, then you will use a VPN to securely use the internet or access your files inside that public Wi-Fi network. An example, or you can also say types of VPN. So we have two types of VPN. One is the site to site or office to office. So this type of VPN is basically between two devices, that is from firewall to firewall. Let's suppose you have a headquarter of your company in a city and a branch of that company in another city, and you have multiple employees over here and over here as well. So you can configure site to site VPN between these sites, so that all these client traffic will be encrypted between these two sites. Another one is the remote access, which is employed to office. So let's suppose you have a single employee and he is working from home. So this type of VPN is used on a single client. such as inside your laptop or inside your PC, and you use that VPN to directly connect to the company network. So now some key differences between the VLANs and VPN. So VLANs basically create logical segmentation within a private network, as we studied, while the VPN creates a secure tunnel or a public network. The purpose of VLAN is organization, that is management, security, and it also gives a benefit of performance within a LAN because it divides broadcast domain into multiple broadcast domains. While the purpose of VPN is secure remote access and privacy. Objective 2.5, compare and contrast common networking hardware devices. Introduction to network hardware. So routers and switches are fundamental networking devices, and these devices facilitate communication and data flow within and between networks. So switch is basically used to route or communicate data within a network, but when we need to route traffic between different networks, we need routers. Understanding their distinct function is crucial. First of all, routers. So routers connect multiple networks together. For example, when you are browsing internet inside your home, so your home network is connected to the internet, which consists of lot of different networks. So you need a router to do this routing from your home network to the internet. So router also determines the best path for data packets to travel. So there may be multiple paths from your client or from your device to the destination, but the router selects the best and optimal path for the data packets to travel. Routing or router basically operate at layer 3 or at the network layer of the OSI model. So if you are asked inside exam that routers operate or function at which layer, your answer should be layer 3 or the network layer of the OSI model. On the other hand, switch operates at layer 2. So router basically uses IP addresses to route traffic. And the modern routers have the firewall capabilities where you can block and allow different type of traffic. Next device is the switch. So switches basically connect devices within the same local area network or LAN, and switch forwards packets directly to the intended destination device. What does this mean? This means that the devices are basically connected directly to the switch ports. So for example, if you want to send traffic from this laptop 1 to laptop 2, the router will forward traffic directly to this device. On the other hand, the routers may be forwarding traffic to another router. And the switch operates at layer 2 or the data link layer of the OSI model. So this is important. And switch basically uses MAC address to forward traffic. So when the laptop wants to send data to this another laptop, it uses the laptop IP address. But when the switch actually forwards the packet, it does this using the switch network card MAC address. So each of these switch port has also its own MAC address, and this MAC address of the switch NIC or network interface card, it is basically learned and saved by the switch. So the switch knows that this MAC address of this laptop is basically connected to my port number 3, and so it forwards data through MAC address. So we have two type of switches, that is managed and unmanaged switches, and this is the comparison table of managed and unmanaged switches. So as far as control is concerned, the managed switches are controllable, or you can say configurable. You can configure different features such as VLANs, quality of service inside these managed switches. You can assign IP addresses, etc. While the unmanaged switch, they are basically plug and play. You power on the switch and directly connect your devices to this switch, and they also basically work or operate at the same VLAN one, so you cannot configure different features inside this switch. Security, so it has advanced security features because you can configure VLANs, quality of service, ACL, access control list, etc. So it has basic security features because you cannot configure these advanced features. Cost, it is of course expensive because it has advanced feature, while the unmanaged switch is less expensive. And the managed switch is basically used for businesses and large networks, while the unmanaged switch you can use for small home and office network where you have a few devices. Our next network hardware is the access points or APs. So these allows wireless devices like laptops, mobile devices to connect to your wired network. So let's suppose your access point is connected to the internet through wired network, and your mobile clients such as your laptop and your PC can wirelessly connect to this access point, and then this access point basically allows these devices to access the internet. So they transmit and receive data using Wi-Fi standards such as 802.11n, AC, and X, and the access point basically connect to the wired network infrastructure. For example, other switches using through these Ethernet ports and Ethernet cables. And access point basically provide wireless coverage for a specific area, usually within a 100-meter radius. And this coverage also depends upon the other interference such as walls, trees, etc. If there are less walls and less tree, the coverage area will be more, and if there are thick walls and rooms, the coverage area will be reduced. Next are the patch panels. So patch panel are basically passive devices that centralize and organize network cable connection. Passive means they are not powered. They are basically, these are cables, they are punched at the back of the patch panel, and at the front these are basically RJ45 enable connector connection, so you can plug your RJ45 connector and cable inside these patch panel. So these are passive. Basically, they are the extension of these Cat6 cables. You can use this patch panel for easy management and organization of cables. So they provide termination point for Ethernet cables as shown here from various locations, and they allow for easy reconfiguration and management of network connection using patch cables. So once patched, you can use these patch cables to connect these network or cables to these network devices. So they improve cable organization and troubleshooting. Our next hardware device is the firewall. So these are security devices that control network traffic. So they allow or disallow different devices and network packets to the server or different services. So they filter incoming and outgoing traffic based on defined rules. So you can define different rules on the firewall that, let's suppose this IP address 192.168.1.100 is allowed. It can access services, while another IP address 192.168.1.101, this one is not allowed. So you can configure this type of rules. It can be hardware based, or you can also use software application firewall, such as you must have seen Windows firewall. So this is a software based firewall, while inside organization where we have big networks, we use hardware based firewalls. So it helps protect network from unauthorized access and malicious threats. And it often integrates into routers or UTM devices. As we studied, UTM devices has the firewall functionality built in. Modern routers also have some features of firewalls. Another concept or network hardware is the power over Ethernet or PoE. So PoE basically delays, or you can say this is not delays, it is basically relays. It relays power and data over Ethernet. So this is, you can see, a PoE based device. So this cable brings in data and you connect your, let's suppose this is a camera, you connect this to this another cable. So this camera receives both the power as well as the data from this cable. So you can say that, as the name indicates, power over Ethernet, this device receives power over this Ethernet cable. This is normal Cat6 or Cat7 cable. And multiple devices are supported, can use the PoE functionality, such as the IP cameras, voice over IP phones, wireless access points, etc. And we have different standards of PoE. Simple PoE, which is 802.3 AF, it gives power up to 15.4 watt. PoE Plus, which is 802.3 AT standard, it gives power of up to 25.5 watt, and the PoE++, which is 802.3 BT, it gives the largest power, which is 51.7, which is 51 to 27 watt. So what are some different components of PoE? One is the injector. As we saw in the previous diagram, this one is basically injector, which injects the power. So the injector basically used to add PoE capability to a network segment. So as we saw in the previous example, your network cables come over here and you then take an exit cable that is connected to the device, such as IP camera, that requires power as well as data. So it is connected between a non-PoE switch and the PoE powered device. So the switch here, this switch does not have built-in PoE ports. So that's why you can use this power injector with this un-PoE switch. Take power from a, so this PoE basically takes power from a wall outlet and inject it onto the Ethernet cable. So this is powered by your normal home power supply or power outlet. So another thing is that modern switches have built-in PoE ports. So these network switches with built-in PoE functionality provide both data connectivity and power to the connected PoE-enabled devices. So this simplifies network deployment, because with the PoE-enabled switches, you no longer need these PoE injectors. So your network is simple without an additional device such as PoE injectors. Our next appliance or network hardware device is the cable modem. So it connects devices to the internet via coaxial cable that are used for cable television, such as this. So these provides high-speed broadband internet access, and they basically modulate and demodulate signals for data transmission over cable infrastructure. Next device is the DSL, which is digital subscriber line. So it uses regular telephone line that is twisted pair. As you can see, this connector is basically where the telephone line or cable plugs in, and this connector is known as RJ11. So this is smaller than the Ethernet RJ45 connector. So the types of DSL includes ADSL, which is asymmetric digital subscriber line, and it gives faster downloads. And next one is the symmetric DSL or symmetric digital subscriber line, which has equal downloads as well as uploads. So the asymmetric has faster download but slower upload. Usually we don't upload much, we download things, we download much more than we upload. So in the ADSL we have faster download speed but slower upload speed, while in the SDSL we have equal upload as well as download speed. So it is distance sensitive since it uses the copper twisted pair cable, so it works at limited distance. So if the distance increases from your ISP, the speed also decreases. And in the modern network, we uses the optical network terminal or ONT for internet connectivity. So it is used in the fiber to the home or FTTH networks, and it connects a user's device to the fiber optic cable. So it basically converts optical signals from the fiber into electric signal that devices can understand. And benefits of ONT are that they give faster speeds of up to 10 gigabit per second because they use optical fiber. So optical fiber has greater speeds as compared to the copper or Ethernet cable, and they are more reliable than copper. They also work at longer distances as compared to copper. So let me get back. So this is an example of an ONT. So basically, this is the fiber that is coming inside your network. This is a dumb devices. This fiber optic is spliced over here, and then a cable is exited from this fiber device. It is not powered, it is passive device, and it enters your ONT. So this is fiber optic port, and then you can, this is also most of the time a Wi-Fi enabled device, so you can use wirelessly. Your device can connect to these devices through Wi-Fi, or this also has Ethernet ports. You can also connect your device through Ethernet cable. So now some comparison of internet connection types. So the cable modem uses the coaxial cable. The medium is coaxial cable. DSL uses the phone line, which is also basically copper cable, and the fiber or ONT using fiber optic cable. The speed, cable modem has up from 100 Mbps to 1 Gbps. DSL and this cable modem are rarely used nowadays. ONT is the latest standard. So DSL has a speed of 5 to 100 Mbps, while the ONT has it is the fastest of all. It has 100 to 10 Gbps per second speed. Latency, so cable medium has medium latency. DSL has the highest latency, while fiber optic or ONT has the lowest latency of all these. Next topic is the network interface card or NIC. So this is hardware component in a device such as your computer or network that allows it to connect to a network, and it provides a physical port such as this one, that is Ethernet, or it can also be a wireless. It can also be wireless capable port that is not visible but embedded inside the device, such as your laptop. So the types of network interface card may be integrated, such as inside your laptop, PCIe add-on cards such as this one, or USB adapters such as this one. So these are integrated ones. These are usually found inside switches as well as your modern day laptops, while these are used for some devices such as your Apple MacBook or other slim laptops may not have the RJ45 connector. Then you can use the USB enabled RJ45 adapter. Another topic is the physical media access control address, that is MAC address. So the MAC address is basically unique hardware ID on every NIC or network interface card that we just studied. So it is 48-bit address such as this one. These are hexadecimal digits. So the first three octets are known as OUI, that is original. I don't remember this abbreviation right now, but this OUI, the first three octet identifies the manufacturer. So let's suppose if this your NIC, your laptop is from Dell, it is most probably these initial three octet will represent Dell, and the last three octets they are device specific. So this will be unique to this laptop. If there is another Dell laptop, this will be same, the first octet, because they will again represent Dell, but this will be different because this is unique for each device. And these are also used by switches to forward data. So switch port RJ45 or network interface cards or ports also have their own MAC addresses, while the laptops or devices that are connected to these switch ports, the switch also forwards the data to these devices using these MAC addresses, as we just studied. So the MAC address basically works at layer 2 or data link layer. So this is important. So now a quick quiz time. So the question is, which connection type uses light pulses for data transmission? And the options are cable modem, DSL, ONT, or NIC or network interface card. And the correct option is, of course, ONT, optical fiber, because optical fiber basically uses light for data transmission. So the ONT basically works with optical fiber, while the rest are basically use electrical signals. Objective 2.6, given a scenario, configure basic wired and wireless small office, home office, that is SOHO networks. And our first topics in SOHO networks is IP addressing, understanding IP addressing. So devices inside the network need IP addresses to communicate with each other. And the IPs can be manually or statically assigned to the devices, or they can be assigned through DHCP dynamically. So the IP can be IP version 4, IP version 6, and APIPA. So we will study all these concepts in a while. So all these concepts play a vital role inside our SOHO networks. So first of all, the IP version 4 addressing. So IP version 4 uses a 32-bit address format such as this one, 192.168.1.10. So these are decimal digits, or you can say octets, and each octet is 8 bits. So 4 into 8 is equal to 32 bits. So the IPv4 address size is 32 bit. And there are limited number of available addresses due to the fact that we have 2 raised to the power 32 addresses. So these are already exhausted, so limited number of IPv4 addresses available. And IPv4 is further divided into public and private IP address ranges. So what are these two ranges? So the private IP addresses are basically reserved for use within private networks such as your small office, home office network, or inside organization private networks. And since these addresses are used inside private networks, inside your home, inside your office, so they are not basically routable on the public internet. So what does this mean? This means that, let's suppose you have a website such as the google.com. So google.com cannot use a private IP address because people are accessing google.com over the internet, and since private IP addresses are not routable over the internet, you cannot use IPv4 address over the internet. And The private IP addresses have basically the following ranges. So the first range is from 10 to 10.00 to 10.255.255.255. So anyone and everyone can use these addresses inside their private lanes. Second range is 172.16.00 up to 172.31.255.255. And the third range that most commonly used is 192.168.00 up to 192.168.255.255. These can also be written in this format. The first one is 10/8. Second one is 172.16/12, and the third one is, sorry, let me get back. The third one is 192.168/16. So this number basically use the number of bits that are reserved for the network. So in the first one, only the first octet, the 10, is for network. Rest all the octets can be used for host addresses. Similarly, in this network, the first 12 bits and the first 16 bits are the first two octets are reserved for the network and the last for the host. Next is the IPv4 public addresses. So as the name indicates, these addresses can be publicly used over the internet, and these are basically globally unique addresses assigned to organization. What does this mean? This means that if a public IP address, let's suppose 8.8.4.4, is assigned to an organization, it is unique. It cannot be assigned or cannot be used by anyone else, while the private IP addresses can be used by everyone inside their own private network. So they are routable on the internet as compared to the IPv4 addresses. Your home router typically has one public IP address assigned by your ISP. So inside your home router, you use these private IP addresses for your devices such as your PC, your laptop, your smartphone. But when you need to communicate over the internet, your access point or your router has a public IP address. So all the traffic is routed through this one public IP address over to the internet. Devices on your private network use NAT to share this public IP. So NAT is network address translation. What does this mean? This means that, let's suppose this is your router and you have these multiple client devices. So these all have private IP addresses. Let's suppose this one has 10.6.1.5 and this one has 10.6.1.6. And these are connected to this router, and this router is thus connected to the internet. And this router has a public IP address, let's suppose 200.4.3.1. So when a client wants to access the internet, the request comes to the router. The router then translates this IP address to this. So the request is forwarded to this IP address. It is basically translated. You can say that this is the source address translation. So the source IP is this, but it is translated into this public IP address. And how does router remember that since multiple clients are accessing the internet and there is only one public IP address? So here comes the port numbers. So for this client, the router associates this with a port number, let's suppose 45,550. So this is the port number, and for this there will be another port 45,551. So it remembers the request and sessions using the port addresses. Next is IPv6 addressing. So IPv6 as compared to IPv4, it is 1 to 8 bit long and it is in hexadecimal format. So this is a format of IPv6. So if you count all these bits, they will be equal to 1 to 8 bits. So benefit is that it solves the IPv4 address exhaustion, and the total number of IPv6 addresses are, if you calculate this, these are 340 trillion. I even don't know this number. So there is a huge number, and they can be used, and they are sufficient for foreseeable future. Another is that it has built-in features, so we no longer use, or we no longer need the network address translation, because this net was used due to limited number of IPv4 addresses. Now, since we have a lot of these addresses, we no longer need the net, and it is not used inside the IPv6, and it is auto configurable. So IP address are automatically assigned to the interfaces, and it has built-in security. So security features that we will study in the coming lectures, such as IP stack, that is IP security, these are built in inside IPv6, and its prefix is like this prefix. When you see this prefix, it means that this is for local networking or for local communication. Another concept is the automatic private IP addressing, also known as APIPA. So this is basically used when DHCP server is unreachable or when it fails. So for example, you have a client and you want that this client can, or this client is assigned an IP address through DHCP or dynamically. So the client requests the DHCP server, but the DHCP server is unavailable due to any reason, or cannot assign IP address to this client. So here the client is automatically assigned an IP address in this range. Who assigns this IP address? It is automatically assigned by the operating system. So if you are using Windows laptop, it will get an IP address in this range automatically. And the range is 169.254.0.1 up to 169.254.255.254. So if there are multiple clients and all these clients cannot get the IP address, they all are assigned IP addresses from this range, and then they can talk locally through these IP addresses, but cannot access the internet or cannot talk to the internet services. Another concept is the static and dynamic IP addresses. So the static is when you assign a static or manually IP address to your device. So these IP addresses are manually configured on each device, and they require careful planning to avoid IP address conflicts. So this means that you should carefully plan so that you don't assign same IP address to multiple devices. And if you do this conflict, if you assign multiple devices and same IP address, they won't be able to communicate over the network, and the network will also be congested and performance will be degraded. So it is suitable for devices that need a consistent IP address, such as printers. While on the other hand, dynamic IP addresses are assigned to the clients through DHCP. So devices obtain IP address automatically from a DHCP server. We have studied this multiple times. It simplifies network administration and reduces configuration errors. The most common method for client devices in SOHO networks, such as inside your home, you have the access points, such as a Wi-Fi router, and your devices automatically get IP addresses from this access point through DHCP. Another concept inside IP addressing is the subnet mask. So this is the thing is known as the subnet mask, the IP address, and then you write the subnet mask that defines the range of this IP address. So it defines the size or the range of the network. Common subnet mask of class C that we use inside our home, such as with these IP addresses, is 255.255.255.0. It is suitable for smaller network. and it has up to 254 IP addresses. It helps determine. So another concept in IP addressing is subnet mask. So it defines basically the size of the network, and a common subnet mask that we use inside our homes, inside our private network is 255.255.255.0, which is basically a class C network. And we use this with these addresses commonly, such as 192.168.1.0 or 1.10. So with this IP, this is class C network, we use these subnet masks. It helps devices determine if destination is local or remote. What does this mean? This means that if, let's suppose, you have this IP address and this subnet mask, and let's suppose you want to send traffic to another IP address such as 192.168.1.5. So this device now knows that this IP address is in the same network, and it can send the traffic locally using or through switch, or in it does not require a router to send traffic because they are in the same network. Let's suppose there was another IP address 192.168.100.5. So now these two IP addresses, this and this, are in different networks. If the subnet mask is same, this network then ranges from 192.168.1.3 up to 192.168.1.254. So this IP is out of this range. It means that this is a remote network, and then we need a layer 3 device or router to reach a remote or a different network. Another important concept, default gateway. So it is the IP address of the device, usually the router, that allows a local network to communicate with other network, for example, the internet. So devices send traffic destined for outside local network to the gateway, and it must be correctly configured for internet access. So let's have a look over here. So here, let's suppose this is your PC IP address setting. So you have this IP address, the subnet mask, and this gateway. So what does this mean? This means that this router has basically this IP address, and you are telling your PC that you should send all your traffic to this gateway. As if you look at the terminology, default gateway, this is your default door or your default route or your default gateway to all traffic outside your network interface. So any type of traffic that it wants to send, whether it is local or whether it is to the internet, it will be sent to this router or to its default gateway. So this is a sample small office, home office configuration. So the router or the gateway has basically an IP address, as we saw in the previous example. This IP address is used as a default gateway by all the clients. So this is the router interface, as we saw in the previous example, this SOHO router configuration or web interface. So this is router IP. It will act as a default gateway as well as a DHCP server for all the client inside the LAN. And you can define the DHCP range, such as here, the start IP is 192.168.1.100, and the last or the end IP is 192.168.1.149. It means that the clients will get IP addresses from this range, and so a total of 50 clients can be given the IP addresses through this DHCP range. Remember, we called this as DHCP scope in our previous slides. So again, we have the we will have the subnet mask of this 255.255.255.0, and the DNS server can be your router, or you can use an external DNS such as 8.8.8. you can give the DNS IP addresses. So this is a public DNS server from Google. You can use it inside your clients. You can define this. This is one. Another Google public DNS server is 8.8.4. So you can manually configure them over here as well. So summary of the SOHO IP addressing. So IPv4 is the standard that has been used, but IPv6 is gradually going, and IPv4 is gradually replaced by IPv6. So the private IP addresses are basically used inside your local SOHO networks or inside the LAN. DHCP assigns dynamic IP addresses to the client, while static IP address is manually configured. Subnet mask plus gateway basically control the traffic flow. If your IP addresses are in the same network, then the clients can communicate inside the same network. If the network is remote, then your traffic is sent to the gateway, and then the gateway then sends this traffic to the internet. A PIPA is used when your DHCP server fails or when client fails to get IP address from DHCP dynamically. It is assigned an IP address in this range by the operating system. So if all these clients cannot get IP address from DHCP server, let's suppose, they are assigned this IP address in this range, and then they can communicate locally over the LAN. Objective 2.7, compare and contrast internet connection types, network types, and their characteristics. So the first topic is in the internet connection type is the satellite internet connection. So the satellite internet basically uses satellites that are orbiting the Earth to transmit and receive data. So it is basically crucial for availability of internet in rural and remote areas where wired options are limited, such as in mountainous areas. Higher latency or delay, the satellite internet has higher latency, or you can say the delay compared to wired connection. Why? There are multiple reasons. First, the distance is huge, and secondly, there are interference in the atmosphere, such as you can say the clouds, the dust, the other things that increases the delay. In wired connection, you have no such delay because the traffic moves through the wire. There are delay, but not as much as in the satellite internet. And the speed of internet can vary, but generally slower than the fiber or cable internet. And the most popular satellite internet nowadays, if you see at this device, is from the Elon Musk Starlink, which is a revolutionary satellite internet, and it is expanding to multiple countries. It is now available in many countries and gradually expanding to other countries as well. So it offers a very high speed internet, and you can use it anywhere, anytime. Another internet connection type is the optical fiber, and this uses the thin strands of glass or plastic to transmit data as light pulses. So it offers very high speeds in gigabits and beyond, and it has a very low latency as compared to the Ethernet or copper or satellite internet. So the OFC, you can say, it offers the highest internet speeds. It is more reliable and less susceptible to interference than copper-based technology. So the copper, such as this Cat6, they are susceptible to interference from electrical signals, while the fiber, since it uses light, it is not susceptible to electrical interference. And its availability is still expanding, but nowadays in modern time, it is almost available to every home in urban areas and to every office. The latest modern ISPs basically provide you the internet connectivity through fiber inside your home, which is known as FTTH, as we already studied, fiber to the home. Next is the cable. So it uses the same coaxial cable that deliver your cable television through this type of cable. So it offers relatively higher download speeds, but upload speeds are often lower. And it works on the shared bandwidth with other users in the area, which can affect speeds during peak times. So if there are congested populated area and many users are using the same shared bandwidth, so the speed will be low, specifically during peak usage time. And it is widely available in many residential areas. Next is the DSL, or digital subscriber lines. So this was also used 2 or 3 decades ago. It is also relatively old and is being replaced by the optical fiber. So it uses the existing copper telephone lines to transmit data. By this connector, you can guess it is the RJ11 connector that was used inside your telephones. So you can use this ADSL modem and your existing telephone lines to access the internet. Speed and availability depends on the distance from provider's central office. So if the central office, ISP central office is far, speed will be uh, used, it will be low, and if it is near, so speed will be high. And it has various types, as we already studied, such as ADSL and VDSL, and each offer different speed. And it is slower as compared to fiber or cable, especially if your location is further from the central office or from the ISP. Another type, emerging type in the 5G and 4G era, is the cellular internet. So it uses mobile phone networks such as 3G, 4G, LTE, and 5G to provide internet access. It is convenient for mobile devices such as your tablets and smartphones and areas with limited Wi-Fi options. Speed and data allowances can vary based on the service plan and network congestion. So latency again can be higher than wired connection because again it is wireless and there are multiple interferences inside the base that can affect its speed. Another internet connection type is the wireless ISP or WISP. So this basically provides internet access wirelessly using radio waves from towers to antennas at the customer location. So it is just like the cellular, but it is different from the cellular. Uh, if you have heard of WiMAX, so it works such that there is an antenna at the customer premises, and these antenna basically transmit and receive data to this customer antenna, and this customer antenna then delivers internet to other, let's suppose this is a switch, and other client devices can then use internet through this wireless connection. It often serves rural or underserved areas where wide options are limited, and speed and reliability can be affected again by weather and distance. So now coming over to some network types. So the networks can be defined by size, scope, and function. They can be smaller, such as LAN, or huge or larger, such as WAN, and specialized network for personal or storage or for storage use that we will study in upcoming slides. So the first network and the smallest you can say is the PAN, also known as the personal area network, and this is the network that is used for the Bluetooth connectivity, or if you say, you can say the wired example of PAN is the USB connection, which is in about which have about 1 meter range. Bluetooth maybe may have up to 10 meter range. So this is your personal area network that you use inside your you can say your room or your home. Another greater network with respect to size is the LAN, which is the local area network, which you use inside home or offices network, such as this one, which uses the Cat6 cable, and it has a greater range of up to 100 meters, which can also be increased if you use multiple switches or multiple routers. Next one is the wireless LAN. So it is similar to this one, but this is wireless. It uses access points like this one, and commonly it uses the IEEE 802.11 standards, such as Wi-Fi 5, Wi-Fi 6, etc. And then, so we are going from smaller to larger network. The next network which spans about a complete city is the MAN, which is Metropolitan Area Network. And it is a citywide, as you can also say, it can be used in a big campus networks. And even larger than the MAN is the WAN, which is the wide area network, which spans countries, cities, or even the whole world. And the largest of the WAN is basically the internet. So it connects LANs all over the long distances and all over the world. The largest WAN in the world is the internet. There can be other WAN by the organization. They can have private WANs as well. But popular example of WAN and the largest WAN is the internet. A specialized network is the SAN, which is storage area network. So it is a high-speed storage network for servers. For example, this may be your storage inside your organization, which basically have multiple disks, and it has the availability capacity, and it provides storage capacity in terabytes and in petabytes, and the servers basically access this storage from this central location. So now coming over to comparison of these different network types. So span, if we compare, the range is the smallest of all. It is equal to or less than 10 meters. Speed is slow. If you have used the Bluetooth data transfer or connectivity, so its speed is slow. An example is the Bluetooth headphone or transferring data between smartphone or Bluetooth. Next is the LAN. So LAN has a range of less than 1 kilometer. Speed is 1 gigabit plus 1 gigabit per second plus. So as we already studied that Wi-Fi 6 has up to 9.6 gigabit per second. And its example is your office Ethernet or your home LAN or home Ethernet. Next is WAN, which its range is global up to 100 and 1000 of kilometers. Speed may vary depending upon your ISP connection or the connection you are using. If you are using OFC or FTTH, your speed may be high. If you are using the DSL or copper lines, your speed may be low. An example of WAN is the internet, and then again the SAN. Its range is basically the data center that an organization is using. Data center may spans up to a building. You can say roughly that it's is up to few meter. You can say 10 meter, 20 meter. Its range is because it uses OFC cables, and it is used inside the data center. Its speed is 10 gigabit per second plus, and its example are NAS. NAS is network attached storage or enterprise storage. So our last objective, objective 2.A of this domain, is explain networking tools and their purposes. And the first tool is the crimper. So it basically attaches RJ45 connectors to the Ethernet cables, such as this one. It compresses pins into the wire pairs, and it is used to make custom cables. What does this mean? So we have prepaid Ethernet cables of different lengths, such as 5 meter, 10 meter. Let's suppose you need a Ethernet cable of 70 meters, so you can get a 70 meter Ethernet cable and attach RJ45 connector on both its ends using this crimper tool. Next is the cable stripper. So it removes outer insulation layer from this Cat6 or Cat7 cable, and it prevents, it exposes the twisted pair cables such as these one, and it prevents wire damage. It prevents damage to the internal wires. Next is the Wi-Fi analyzer. So it may be a software based, such as a software that you have installed inside your laptop, or it may have a Wi-Fi analyzer, maybe a hardware specialized tool that scans the wireless environment. And the display of this analyzer basically displays nearby Wi-Fi networks, and it displays this information such as the SSID of the network, the signal strength, the channels, and the security type used by the Wi-Fi networks. And this Wi-Fi analyzer is basically used to identify congestion, interference, and optimal channel selection as discussed in the wireless networking. Another tool is the toner probe kit. So what is this? So it is a two-part tool, part 1 and part 2, to identify specific cables within a bundle. So how does this work? So the toner, that is the tone generator, sends an electric signal down the cable. It is basically this one is the sender. So you attach cable over here to this part and it sends a signal. And the probe, this one, so this one is the probe. So the probe or the inductive amplifier emits a tone when near a cable carrying the signal, this one. So this also emits a tone when near a cable carrying the signal. So it is useful for tracing cables in walls, ceilings, or page panel without physically following them. So I hope you get the point. So you send signals through this device by attaching a cable to it, and then you go with this device, you press this button, and then it will show that where is the strongest signal. So at the end of the cable you will get the strongest signal, and you will know that where this cable ends or where this cable goes. Another tool is the punch down tool. So it inserts wires into page panel or keystone jack. Remember, we studied the page panel. At the back of the page panel, we insert these cables inside the page panel using this punch down tool. And it can also be used to cut excess wires while seating it into these places. It ensures tight connection with insulation displacement. Another popular tool used by a network technician is the cable tester. So it is used to check the continuity and the wiring order of the network cable, specifically the Ethernet cables. So it can identify common issues in the patch cards or the cables, such as open circuits, it means the broken wires, short circuits, wires incorrectly connected, and cross pairs wires in the wrong order. So it has all these wires number 1, 2, 3, 4 up to 8, and it can show you the if the order is wrong, if there is short circuit, and etc. So it has two ends. You connect one end at the one part of the tester, and other end at the other part, and then you press the button, the test button, and then it gives you the detail of the cable. If it is good, it will show you the result. If there is some issue, it will indicate the issue. And it is essential for ensuring proper cable termination and network connectivity. Another important tool, it is a small tool but important to test connectivity and test network card, is the loopback plug. So it is basically a simple connector used to test the functionality of a network interface card. It is basically, you can say, an RJ45 connector that is loop backed inside to test your, you can say, different network interface cards. It physically connects the transmit pins of a port to its receive pins. So the transmit pins and the receive pins are basically connected and looped back. So when you connect this to a port, if the port blinks and becomes up, it means the port is working, because the port then sees that traffic is coming, it receives and transmits the packets through this loopback cable. So it allows you to send data out of the NIC and have it immediately loop back in, verifying the NIC's basic operation and functionality. So this is for Ethernet cable or for RJ45 connector. To test RJ45 cards, this one can be used to test the fiber interfaces. This is fiber loopback plug. Another tool is the network tap. So it is a hardware device that allows you to intercept and monitor network traffic without interrupting communication flow. So it creates a copy of the network traffic that can be sent to the analysis tool, for example, packet sniffer. It is passive and non-intrusive and ensuring no impact on live network traffic. So how does this work? So basically, let's suppose you have a switch over here and it has multiple ports connected to different lines. Also, let's suppose connected to the internet. So you can configure one port, and you can configure it such that all data that is received or all the ports is sent to this port. And then you again take another cable out from this port and connect it with a packet analyzer. Let's suppose this is a laptop and you have Wireshark, which is a tool to inspect network traffic. You have a Wireshark installed over here. So here you can monitor and you can analyze all the network traffic, because all the network traffic is copied to this port over here and then it is replicated to this device. So this is how this network tap works. So the summary of the networking tools and for which and what purpose they are used. So to build network, you need the crimper, which is this tool to connect these RJ45 connector to the cables. Stripper is used to strip this out layer of the cable, and punch down tool, as we studied, is used to punch the cable at the back of the patch panel. To trace the cable, you need toner probe tool. For testing different network or cable, for RJ45 you can use this testing tool, cable tester, as we studied, or for the network interface cards you can use the loopback plug. To analyze network, for wireless network, Wi-Fi network, you can use the Wi-Fi analyzer, and for the wired network or Ethernet network, you can use the network tab. So that's all for this domain. Thank you for your support. Thank you for watching the video. So please subscribe, like and share the video, and stay tuned for the next domain.